So in today's lecture, we are going to discuss about the structural attributes of a plant community. Now we have already discussed what is a plant community. When at a particular place, the group of populations of different species interact with each other, they coexist, that forms a community. Okay. So we are going to discuss about its structural attributes, means structural characters. In the previous lecture, I told you that there are three different schools of scientists which have worked upon different aspects of plant community, and amongst them the most common one, that was Zurich Montpellier school, which is working on the advanced characters of plant community, that is basically plant sociology. Okay, and the followers of Zurich Montpellier school, they are Henson and Braun Blanquet, who are actually working on the calculation of these attributes. So the scientists, they are the Zurich. This is a school, Zurich Montpellier, and under the school, scientists Henson and another group of scientists is Braun Blanquet. Okay, and he is the recent one who worked on this in 1950, and they worked in 1932 on the concepts of the Zurich Montpellier school, and they gave the basic attributes which were further categorized into the qualitative and quantitative characters of a plant community. So we have the structural attributes further categorized into the analytical and synthetic characters. Now, what is the difference of these analytical and synthetic? What is the concept actually? What are the analytical characters? These are the characters of a community which can be measured or observed directly in each stand. Means whenever you visit a particular place, for example, you have to lay 10 quadrats in an area. So that area will serve as a stand. Okay, and in that stand, whatever you can observe, whatever you can measure directly, for example, you can see number of species there, the distribution of different plants there, what is the height of the plant. So all those measurable or observable characters, that in that stand, it is called analytical character. Whereas what is the synthetic character? Synthetic character, basically these are those aspects of the community which are based on analytical characters, and they utilize data obtained in the analysis of a number of stands. Means basically whatever data you get from the analytical characters, that is utilized in the synthetic one. So we are not having any direct observations from a single one. Rather, we have, for example, let's suppose you measured height of plants in this, you measured distribution of plants in this, frequency of plants in this, and that is somehow all these data is being utilized for some other character, for example, physiognomy of the plants. So the physiognomy becomes the synthetic character. Okay, so analytical characters, they are further of two types, the quantitative one and the qualitative one. Quantitative characters means which can be measured more readily than others. For example, let's suppose you are talking about the density of plants. Okay, that you can measure. You are talking about the height of plant, that can be measured. So all these are quantitative characters which can be measured. Whereas qualitative characters which cannot be measured but they can be observed. Okay, they are called qualitative characters. For example, we have different kind of life forms. So you cannot measure the life forms. Similarly, you are studying the sociability of different plant species in an area. Now, sociability cannot be expressed in terms of certain values. So all those which can be observed but cannot be measured, they are called qualitative characters, whereas those which can be measured, okay, they are called quantitative characters. So once again, the structural attributes of plant community, they were provided by the third school of ecologist scientists, which basically dealt with plant sociology, and that school is called Zurich Montpellier School. And the followers of this school, that is Henson, Braun, Blanket, they divided the structural attributes into the analytical characters and synthetic characters. Analytical characters which can be observed or measured. I told you these they can be measured, these can be observed only. So all these characters of a community, they are called analytical one. Whereas when you talk about the synthetic characters, means whatever information or data you are getting from analytical one, when that is used in order to explain certain kind of interactions, some kind of structure of a plant community, so that those characters, they are called synthetic characters. So basically they are derived from the analytical one. Okay, so this is how we broadly categorize the structural attributes of a plant community. So this is a broad categorization of the quantitative characters and the qualitative characters. So we will study here frequency, density, cover, abundance, dominance, importance value index, which is abbreviated as IVI. Then species diversity indices, they are there in your practical also, and these are associated with these. So all these characters, they are quantitative, means we are able to calculate them. So they are measurable. Whereas the qualitative characters, which can only be observed, we cannot measure them. For example, when we talk about composition, when we talk about phenology, phenology means how the plant is changing its morphology during various phases of life. Okay, it cannot be measured. Similarly, the growth forms, the vigor, interspecific interactions, what is the dispersion of population, is it random, is it clumped, what is the stratification of a plant community, what kind of life forms are present there, what kind of metabolism they have, right? So all these which cannot be measured but only observed, they are called the qualitative characters. Okay. Now today we will start with the very first parameter in the quantitative type, which is called frequency. Now what is frequency? See, as a general term, we say when a species appears again and again, recurrence. So basically what is frequency? That is recurrence. So recurrence means when a species is appearing again and again in your sampling units. Okay, so we will count that. For example, this is a lawn area for which you have to study the plant community, and you lay certain quadrates at different places. Here, let's suppose you lay down total 5 quadrates. Okay, it should be uniformly distributed. Now in this one you found species A, you found species A in this, you found species A in this also. And then what will be the frequency? Frequency will be the number of quadrates in which the species appeared. So it is 3 here. If you express it on percent basis, so that will become 60% because you had total 5 quadrates. Similarly, there is another species which you found in this quadrant only. It means for species B, the frequency is 1 only, but that is 1 upon 5. So that becomes 20%. So frequency means how many times the species is appearing in your sampling units, in your quadrates. Okay, what is a quadrate? Quadrate is a quadratic or squarish area that is selected for sampling of plant species. So whenever we are studying any kind of the parameter in plant community, that is always with the help of these areas which are called quadrates. These are called quadrates. Now their size may vary depending upon your landscape. If it's a forest area, you can go up to 10 meter into 10 meter. If it's a normal lawn area, for example 1 or 2 acre of land, then you can go for 1 into 1 meter square. Okay, so there are different sizes, that is depending upon the area, your area, overall area. So whenever you lay the quadrates, you have to keep this thing in mind that they should be uniformly laid throughout that area. So that is an important point. Okay, now how we calculate this frequency. So frequency is calculated on the basis of this formula. That is, it is the number of quadrates in which a species occurs to the total number of quadrates sampled into 100. So I told you, for example, A appeared in 3 quadrates, so it will be 3 divided by total number of quadrates. So here we had 5 quadrates, so 3 upon 5 into 100, and that will give you the value of 60%. Okay, it's very easy, very simple one. And how we calculate relative frequency? Relative frequency means you are comparing frequency with frequency. How? So you are finding the frequency of a single species divided by frequency of all species present in that area multiplied with 100. For example, you found total 5 species in that area, A, B, C, D and E. Okay, and for this the frequency was 100%, means the species appeared in all the quadrates. Then for this the frequency was 60%. Let's suppose for this it was 40%, for this again it was 40%, and this was a rare species and you found this only in 20%, means one of the 5 quadrates. So what is the total frequency of these? That you will find out, and the relative will be, let's suppose you have to find relative frequency of A species. So the relative frequency of A species will be the frequency of A divided by frequency of all. So here you will add these terms, so it will become 260. So you will divide it by 260 multiplied by 100. So that will give you the relative frequency of A. Similarly, you can find it for B, C, D and E. Okay. Okay, so this is a numerical problem for you. In a particular area, we observed 3 plant species, Cynodon, Oxalis and Euphorbia, and we laid total 5 quadrates in that area. Now you have to find out what is the frequency and what is the relative frequency. Okay, so hurriedly find out frequency of all these species. See, it has nothing to do with the number of plants. You just have to see whether the species is present in the quadrate or not. For example, a Cynodon is present in all, right? All 5 quadrates. So obviously its frequency will be 5 upon 5 into 100. So it will be 100%. Oxalis is present in 3 quadrats. So it will be 3 upon 5 into 100. And Euphorbia is present in 2 quadrats, so that will be 2 upon 5 into 100. So on this basis you will calculate frequency and you will take the total of these frequencies, that will become total frequency, and for each species you will write down the frequency of that species divided by total frequency into 100. So it will give you the value of relative frequency. Okay, so this problem you can solve. This is a solution. So we found out that for Cynodon it is 100%, Oxalis 60% and Euphorbia 40%. So the total comes out to be 200. So how you will find out the relative frequency? That will be the frequency of A 100 divided by total 200 into 100. So this comes out to be 50. Similarly, you will find out it for Oxalis as well as for Euphorbia. So it's a very simple experiment. Just you need to equate in order to find out frequency and relative frequency. Now there is a common observation. Different scientists they have observed, and to be very precise, I'll say there are certain scientists who have classified plant communities into 5 different frequency classes. Okay. And the very first work related to this, that was done by Ronquier, and it is IAER. Okay, spelling is RAUNKIAER, Ronquier, and he proposed this classification in 1934. Now, after Ronquier, many other workers, they worked and on different plant species, and on the basis of frequency, they assigned them 5 classes. Now, what are those 5 classes? They were simply named in the form of alphabets A, B, C, D, and E. These were the 5 classes, and on the basis of total how many plant species they studied, it was 8078. Okay, so these many observations were taken, and on that basis they said that there are total 5 classes of plants. So A, they started from 0 to 20% frequency. B is from 21 to 40% frequency. C is again next 20% slab, then 61 to 80% and 81 to 100%. This is how, on the basis of frequency, for example, cyanidon is having 100, so it belongs to class E. See, this is having 60, so it belongs to class C. Okay, this is how the classes were assigned, and that was on the basis of total 8078 observations. And in reality, when they studied these much plants, and they found in nature, okay, the frequency ratio observed was that A was found to be 53%. Then B was found to be B frequency class. These are called Ronquier frequency classes. B was 14%, C was 9%, D was 8%, and E was 16%. So this is the ratio that they observed in nature. Okay, that we'll discuss in the form of Ronquier's law. Okay, so what was the statement here? See, the statement is that species with low frequency, they are higher in number. So you can see here, A has the minimum frequency. It's a 0 to 20% slab. But when they observed in the real plants, they found this the maximum one. 53% plants, they belong to this category. Then the species which had higher frequency, which have higher frequency, those which belong to D or to E. So they observed that, see here, the plants belonging to categories, they are lesser in number. So a general correlation was that the species with low frequency, they are higher in number than the species with higher frequencies. So this is another exercise for you. You are finding here the frequency. Cyanidon is present in all, so it is 100% frequency. Oxalis is present in 3, so 60%. Okay, Mesos is present in 2, so 40%, so on. So you can find out frequencies for all on this basis. Okay, so I told you that Ronquier identified frequency classes on the basis of study on plant communities. Total 5 classes, they were identified by Ronquier and other scientists. It was A, B, C, D, E. And 20% slab was given to all these classes. Class A, which was having minimum frequency, was found to be the most abundant class. Okay, so the one which is having less frequency, that was more abundant, and so on for the others. And it was seen that B, C, D, they had less distribution, whereas E was higher than D. So on this basis, a Ronquier law was summed up, and that was A is greater than B, frequency class B is greater than C, then C is less than or equal to D, which is further less than E. Okay, so how it is related, I told you. What was the percentage? For A, it was 53%. It is greater than B. B was found to be 14%. It is greater than C. C is 9%. it can be less than or equal to D. So in this case it is 8%, so C is less than D, but it can be equal also. And D is less than E, where E was 16%. So this is the general percent they found for different classes. So on that basis, this was called the Ronckhier's frequency law for normal distribution. Okay, this is for normal distribution. But as we see that whatever information is here, that is actually meant for the homogeneous population. So this information is the ideal one, and it does not exist in the systems, in the nature itself. Because why this is not always true? Whenever you are studying a particular plant community and you want to establish this law, this is not necessary that always this law will hold true. Why? Because we may have certain influences in that community. For example, there may be clumping, there may be patron in a particular species, herbivory may be there, so that may result in an unequal distribution. So it may not give you a normal distribution. Okay, so this law, Ronckhier's law of frequency distribution, may not be true always. Now, what information is provided by this law? This says that it tells us about the homogeneous and the heterogeneous nature of vegetation, and it says the class B, C and D, they are relatively high in heterogeneous stands. So these three, if these values, their percentages are high, it means it's a heterogeneous stand. But if E is high, because E correspond to last category, 81 to 100%, it means those species are present in almost all quadrats. So in that case, it will be a homogeneous strand. So it depends. If more of the class E is present in that area, it will be a homogeneous strand. If it is B, C and D, they are the majority, then that strand will be heterogeneous strand. Okay, and this part I already told you that always the distribution doesn't follow the frequency law, the Ronckhier's frequency law. This is not true always, and it is influenced by clumping. Just hold on. So it is influenced by clumping. There may be irregular dispersion. There may be many other factors involved that finally result in some changed relationship between these frequency classes. So this is a kind of dispersion. You will find this law hold true if there is a uniform dispersion, but you can see clumping, that majority of the communities, these species, they are existing in the center, and rest of the outskirts of that landscape, they are totally empty. Similarly, there can be a kind of the irregular dispersion, that at few places you find number of populations coexisting, but there are a lot of gaps in between. So these are kind of the irregular dispersion. So under these circumstances, this law, Ronckhier's law of normal distribution, doesn't hold good. So how we calculate Ronckhier's frequency? This is there in your practical also. For example, we have these different species which you enlisted in a particular landscape in order to study plant community there, and you lay total 5 quadrats. On that basis, you can find out frequency. Now you know the procedure, how we calculated this, and you can assign its class also. Okay, so once you have found out, different classes. So now you know there are total 4 species which belong to class E. There is 1 species which belong to D, 2 species which belong to class A, and 1 which belong to B. Okay, this you have to assign on the basis of these percentage values. Now you will write the frequency of each of these classes. For example, I told you for A it is 2, for B it is 1, C appeared. We had no information about C. No species belong to class C. So C is 0 here, D is 1, and E appeared 4 times. So we will just add these values, and this will give us the total frequency. Now how to calculate relative frequency? That will be the frequency of particular species, class A, then divided by total into 100. So it will be equivalent to 25. Similarly for this, it will be frequency of that class divided by frequency of all classes into 100, and so on. You will get these values. Now you can see here, okay, what law we had. A is greater than B. It's correct. B is greater than C. Again it's correct. C is less than or equal to D. Here also it is correct. And D is less than E. So in this case, the law of normal distribution that holds true. And here you can see the maximum percentage is of class E. So I told you if E is more, that means the particular stand is homogeneous. Whereas if we had another example in which B, C, D are more, then that stand will be heterogeneous. So this is how for a particular area you find out this equation, whether it holds true or not. And secondly, on that basis you deduce whether the particular plant community, okay, that parameter will be for plant community, whether it is homogeneous or heterogeneous. And how we say so? We say so if E is more, then that is homogeneous. If B, C and D classes are more, we say that stand is, it's a word is stand. Stand means that particular area where we are studying plant community. So that stand will be heterogeneous. So in this basis, we find out the type of vegetation in a community. So this is another example. So here we had total 10 quadrants laid down, and on that basis the frequency of species was calculated. They were assigned their classes, okay, and then we found how many times A appeared. It's once. B appeared 3 times, C appeared 2 times, for D also, E also. So on this basis you will have the total frequency and you can find out these relative frequencies. Now you see here A is not greater than B. So here this doesn't hold true. B, what was the equation? That B should be greater than C. So here it is true. C should be less than or equal to D. So here also it is wrong. And D should be less than E. Here it is correct. So it means at these two particular instances, our normal distribution law has not been followed. I told you there may be number of reasons for that. And we see here the maximum is found in case of B and C. E is also more, but if we add these, so B, C, D, if we see more distribution of these species, that say that this particular stand is heterogeneous in nature. Okay, so this is the final outcome after all these calculations. So that's all for today. So once again I am telling you that we discussed various attributes, and those attributes, when we categorize them, then we say, so these attributes, they may be analytical or they may be synthetic. Okay, synthetic, which are derived from analytical, means the data which is obtained from analytical that helps in establishing these characters, they are called synthetic. And analytical are further qualitative and quantitative. Quantitative, which can be measured, and qualitative, which can only be observed. And on that basis we identified number of characters in qualitative and quantitative, and from that we discussed today frequency. What is frequency? Okay, how we calculate the frequency, what is Roncker's frequency classes, how on this basis we say a particular distribution is homogeneous or heterogeneous. So this much you have to learn before your previous class. Okay, so that's all for today.